Hey, welcome. So as I mentioned in the previous video, we're building the SCELBI computer, and we built the ROM board for it. And the ROM board actually supports the 1702 EPROMs from, I don't know, like 1970s, 1980s. I'm not exactly sure when they were or when they became obsolete, but we need a way to program the EPROMs with the SCELBI software, the monitor, the SCELBI computer monitor. And there are 1702 programmers available online, which you can purchase. They are quite expensive though, and also people that might be interested in programming EPROMs for you. If you send them the blank EPROMs, and they'll program them and send them back, of course, for a fee. But I thought it would be good to make our own little programmer to be able to program stuff, reprogram it, and read stuff from the EPROMs. Just to kind of have a little bit more flexibility, and it will be useful for other times when we might need a programmer for this EPROM. So the board that I'll be using for this programmer is this board right here, and it was created by Martin Eberhard, and this is the same Martin Eberhard that created the serial board for the Altair that we assembled in the previous video. I forget when, but a while back. I think it was called the 88 to SIOJP board, and he created that board, and he also created this one. I found that he does pretty good high quality PCBs, so if you want one, send him an email and he'll send you one. I believe this one was maybe like $75 if I'm not mistaken, and he also will send you one of these microcontrollers that handle the programming, and also you can get one of these ZIF sockets from him as well if you don't have one, or you can just get one from like DigiKey or some other place like that. They might be like $5 or $10. So this is the board. There's also a manual for it, an assembly instructions and a manual that you can find online, I believe, or you can get it from him. I actually got it, and I placed it in my little collection of manuals, or collection of just resources for the SCELBI 8B computer. So right here, in my case, I have it all the way at the end. Let me just skip all the way over here. Yeah, so this is the manual, and you can see it's pretty large. It has 75 or so pages, and this is a programmer for the 1702 and 1702A EPROMs. And if we go over here on the welcome page to the introduction, Martin says, "Congratulations on purchasing the newest programmer for the oldest EPROMs." It's kind of funny because here it says the programmer was designed at least 30 years after the EPROMs became obsolete. So, and you can kind of read through it. I'm just going to skim through it and summarize it. Basically, here it says that it has high voltages. We, in fact, have some transformers here for that. So whenever you are programming, well, I guess in the first place, it has the 120 to 240 volts inside the enclosure coming in, but also whenever you're programming, there is, I believe, 60 volts on some of the pins of the EPROM, so you want to make sure you're not touching that. And that's pretty much the essence of this welcome page. And the way that this manual is organized is, first of all, it has the welcome sheet and then the revision history, and the latest revision was October 8, 2021, so it's fairly recent. And then if we skip over that, we got the contents, the index of all the pages, and then it kind of describes on how the assembly will go. Basically, we'll follow the silk screen most of the time, and if anything doesn't make sense on the silk screen, we'll reference the parts layout in the manual here on a piece of paper. And the basic idea is what we've been doing for other boards as well. We're going to start with the smaller components first, the lower profile components, and then kind of work ourselves up. And we'll also install unusually shaped or large components as well first, just so we don't install different components in the wrong place. That is pretty much it. So the rest of the manual, or at least most of this, I don't know how far it goes, but majority of this manual is just the assembly instructions. So we're just going to follow these assembly instructions. And here it says to install the following quarter watt 1% resistors. And I think we have to be very careful with what kind of resistors we use. So like as you can see here, these are the 1% tolerance resistors. These are 5% and so on. And what I actually ended up doing, so since this programmer is not like vintage or anything, I actually went on DigiKey and I bought all the components, which I have right here in the box. As you can see, this box is filled up with components. I have some transformers and also the enclosure right here. I went on DigiKey and got everything there. And in fact, you can see all the DigiKey part numbers here. So you can just go to DigiKey, search for this part number, order it, and everything's right there. Some of the parts, like a few of them, are obsolete, so you just kind of select something similar to the obsolete part. I'm gonna set this manual aside just so I can see it right here on my right, but we'll be able to access the PCB here. So let's start with the assembly. I'm gonna pull out the quarter watt 1% resistors from the box here and start assembling them. So we got all the quarter watt resistors installed. The next component that we'll install are the diodes. And we'll actually install the other larger resistors a little bit later. So let's go ahead and install the diodes. So unfortunately, I can't find the 6.8 kilo ohm half watt resistors that I ordered from DigiKey. I know I ordered them, I just can't find them. Maybe I misplaced them. So I'm going to skip them for now and install them a little bit later. It might be a little bit harder to do it since they're a little bit harder to reach once we have all those bigger components around them. But I kind of don't have a choice right now. I have to skip that and install these. So the next step here, step 6, is install 2 dip sockets, U3 and U2. So let's go ahead and do that. Step 7, we'll install the 13 capacitors. So these are 0.1 microfarad. There are also 2 10K 2 watt resistors. I only have one right now. Not sure what happened to the other one, but I'm going to install one for now and install the other one later. And this voltage regulator, 7909, will go right over here, but we got to, first of all, we're going to mount it flat like this. So we got to bend the leads, but the leads are also not straight. So as you can see, they're kind of like form a triangle. So we're going to form a triangle as well. Next we'll install these right here, and these are just transistors. And I guess one of them is a voltage regulator. And according to the assembly instructions, we should leave some room between the body of the component and the PCB itself. So leave some space, about an eighth of an inch. There's also a bunch of these MPS A42 transistors that we need to install next, and there are 33 of them that we need to install. So this might take a little bit of time. That looks pretty good. I'm going to go ahead and install the skipped components. So I found this 2-watt resistor that I'm going to install. And I also found the 6.8K half-watt resistors also that we skipped here. So I'm going to go ahead and install these right now before we continue. Okay, so now we can install the fuse clips, and this board supports 2 different kinds of fuse clips. So one is, I guess they're oriented like this. Basically, the pins are in line, and those fuse clips, I believe, have basically have polarity. So just want to make sure that you install the fuse clips in the right place. I'm going to be using these right here, and these don't really have a polarity, so it doesn't really matter which way we install them. So let me go ahead and install them. All right, so now we can actually install, so we installed these ceramic capacitors, but now we can actually install the larger capacitors here. So let's go ahead and do that. And I think there are some of these 330 microfarads. So I think this one here is 330 microfarads, 35 volt. There's 2 of them. There's also a bigger one, 330 microfarads. That is 180 volts, but the one I'm using is actually 200 volts. Yeah, so these, I believe these are the same part numbers that the manual actually calls for. In fact, all of these parts are pretty much what the manual calls for. The manual has the DG key part number, and this pretty much I got everything at DG key. Next we'll install the voltage regulators, and there are, I think, 3 different kinds. They also all have heat sinks. So I got these 2 small heat sinks. I also have a heat sink for the larger one right here. One is a LM317. I think that's the one that I have right here. All right. So the way they need to be installed is the heatsink would go like this, and the voltage regulator will sit right against the heatsink. So we want to mount the voltage regulator to the heatsink directly before we actually mount it on the PCB. So I just mounted the heatsink to the voltage regulators loosely. Basically, you can see they're kind of a little loose here. We're gonna tighten it once we install them in the board and solder them in. So let's go ahead and solder in these 2 smaller ones. So this is the 317, and I think that is V4. Now I'm going to go ahead and tighten these. They don't have to be super tight, but we do want the voltage regulator to sit tight against the heatsink here. There was a recommendation to actually add some heatsink compound. It was a thermal paste, but it's not really required, so I'm not going to do it in my case. Then we'll install this power transistor. 2SC4468, and we'll actually add this heatsink to it. The heatsink part number in the manual actually doesn't exist. Well, it exists on DigiKey, but it's not available. There's none in stock. So I just found something that was similar to it, same size and same specs. Basically, we wanted to dissipate the same amount of heat as the other one. So it should actually fit these holes right over here. So once we put it in, let me just... Okay, so this right here needs to be pushed down all the way for the holes to come out. So yeah, it fits the holes, the footprint. And as before, we want to use this spring here. We'll lift it up and put it around the power transistor. Something like that. We also want to, when we mount this heatsink and transistor, we want to lift up the heatsink just a little bit from the surface of the PCB, just so it doesn't short any of these the pins here. It fits pretty well. I left maybe a 1/16 of an inch clearance between the heatsink and the PCB. I'm gonna go ahead and solder in the heatsink pins here. It's actually for the clip. We'll solder that in first, and then we will solder in the power transistor. Just keep in mind that this is a heatsink, so it will require a little bit more heat to heat up and melt the solder. And now we can actually push this power transistor down so that it sits flush with the PCB, well, at least where the pins end, right over there. That looks pretty good. And we'll solder that in as well. Okay, next will be these headers. I think that's what they're called. There's a 4-pin and a 6-pin. We also have this bigger one here, but we'll start with these smaller ones. So the 4-pin one goes over here, and we want to orient it like this, basically. I mean, it's not a big deal as long as the wires are correct that are coming in and going out, but just to be consistent, this tab here will orient it with the PCB tab as well. Okay, that's the 4-pin, and the 6-pin goes over here, and this one doesn't really have an orientation, so we'll install like that, and just want to make sure that they're actually flush against the PCB. And now we can install this bigger one here. It's the 0.56 inch spacing, and again we want this tab to be on the outside against the edge of the PCB. I think I might need to tape it down because it's not touching the surface for it to remain in place. Next we'll install the trimmers right here, and I believe the manual actually calls for these trimmers right here. I think these are the exact part number from DigiKey. For Rev F, which is this board right here, and we need to mount them on this side. The thing is with these trimmers is that, as you can see here, the holes for these trimmers are in line, but these trimmers themselves are not in line. So let me take a look at this one. It's basically like a triangle shape, so we actually need to bend the pins to actually make it work. See, as you can see here, I made them in line by bending the center pin inside a little bit. I believe there are different models, same brand even, that have the pins in line, but I guess I didn't really look hard enough. But I believe this is the same part number that was in the manual, which is why I got it. So just to keep that in mind, make sure that if you don't want to bend these pins, just get one that has the pins in line. And we'll install them on the solder side of the PCB. The manual also states to adjust these so that they're sort of in the middle. So let me see how much adjustment. Yeah, so it's not much room for adjustment, so it's pretty easy to set to the middle. Next, we'll install this ZIF socket, and it's also mounted on the solder side of the PCB. This handle will face towards the towards these trim pots. All right, that's good. That's where the prompts will be inserted for programming. Next, we'll install some LEDs. So let's see what kinds of LEDs we have in here. I also have some LED stands up in this little packet, and these are sort of optional, but these will have the LEDs kind of raised up above the PCB just a little bit. All right, so I believe there are three colors of LEDs. Let me see if I can find them. So there's some green. I believe I just need one of them. I got quite a bit here for later projects. Here's a red one. There's a red, green, and a blue LED. So I just need a blue LED. Yep, and I have one right here, so we'll use that. Okay, so now we can see on this silkscreen side we have LED 1, LED 2, LED 3. So we have LED 1 right here on the top, and LED 1 is actually the blue LED. And we also want to orient them correctly, so this shorter lead will actually be soldered to the square pin. Next, LED 2 is the green one. Also same orientation. And finally the red one. Yeah, so these LEDs and this this socket here will be sticking out through the top here of the enclosure, which is why we're soldering them on this side. All right, let's go ahead and install the fuse here. And I believe we need a 3/4 amp fast blow fuse. Let me see what I have here. I got like some smaller fuses here, but I believe I need a bigger one for my... Yeah, I need a bigger one. I think those smaller ones are probably for something else. And it's also a good idea to get some extra fuses because things happened. So just to kind of be sure that you have some extra fuses to test with. Let me insert that into here. Yeah, that looks good. Okay, we're pretty much finished with all these soldering. Now is a good time to just kind of look over the board, check for solder shorts, any missed pins here. So I'm going to go ahead and do that, and I'll be right back. It might also be a good idea to wash this board with some alcohol and scrub it with I use a toothbrush for scrubbing, so I'll probably do that a little bit later. I also found this interesting right here. So these holes under the 2-watt resistors, I believe they're designed to dissipate here, and that looks kind of cool. Okay, I think we're ready to actually install this this PCB into the enclosure here. So we're gonna do some work on the enclosure next. So this is the box that was recommended in the manual that is available on DigiKey. It's going to be I believe it's supposed to be upside down like this originally. Basically, this was supposed to be the bottom side of it. So it's kind of angled like this, but the way we're going to use it is the other way around. Basically, the metal part will be on the bottom, and this will be inserted into here, something like this from the inside, so that the ZIF socket will be right here, and the LEDs will stick out through here. So what we want to do is drill and cut some holes out for all that. Fortunately, the manual actually comes with templates for that, and if we look at the back of the manual, you'll see these little templates there, and basically it's just on a piece of paper. You're gonna have to cut them out, print them out, and cut them out like this. As you can see, I cut out these holes here for the ZIF socket and so on. So it would go something like this, but it will actually be mounted, I believe, on the inside of the enclosure like this. So it's gonna be upside down like that. And one thing I realized is when I printed these templates, they actually didn't align with the PCB or the enclosure that well. And I actually had to basically expand it to 105% of the page whenever I printed it to actually align it with the PCB. These mounting holes, I think, align with the PCB holes as well. And I cut these out. There's a right side template, got some holes there, and there's also a rear. It's gonna go like this, something like that. There's actually two, so there's two rear templates, rear inside template and a rear outside template. I'm not exactly sure why there's two, but I guess we're gonna figure out eventually. Okay, so what I'm gonna do now is I'm gonna take this enclosure out of this plastic covering here and tape these templates to the enclosure and start cutting and drilling holes out for the PCB, and there's also a power entry module, which I believe is in here somewhere. Let me find it. I believe I got one for it. It's pretty big too. I think this is probably it. No, that's not it. Oh, it's right here. Yeah, so this is the power entry module, which will be used for the power coming in. Looks something like this. So it's going to be mounted in the back, something like this. So the power cord will go in here, and we'll have the switch here. And I believe this one comes with fuses as well. I'm not sure if there's any fuses in there or not, but gotta check on that as well. Okay, so let me go ahead and tape these to the enclosure and start working on it. And this is what it would look like with the templates taped on. As you can see, this is the inside of the template. Sorry, the box, and we have the inside top template, and it goes over the posts here for mounting things. I guess we're gonna mount the PCB to these posts. But yeah, I cut out the holes with a hole punch just so it would go over those posts. The rear side, which is the taller side, has this rear inside template mounted. We also have the rear outside template mounted the same way. As you can see, the box edge side is against this straight edge here where the opening is. Same thing here. And then on this side we have this other template mounted, the right side template. Again, the box edge is right over here, and it's centered horizontally. So now what we want to do is drill and cut out the holes in the templates. Okay, here we have it. So I cut out the holes. This is for the RS-232 plug. This is for the power module here. LEDs, and also the socket for the EPROMs. I actually ended up, like, if you look at the template for this the top part, it says for a ZIF socket you only do this square, but then non-ZIF would include this. I think that's a mistake. At first, actually, since we're using a ZIF here underneath the PCB, I actually just made a rectangular cutout, but then realized that the ZIF has a little lever that actually locks the EPROMs in place so they don't come out, and just all the pins get connected correctly. That plug, that lever thing, needs some room for movement, so I ended up cutting out this part right here as well. Yeah, and drilled out the holes for all the bolts and things like that. Okay, so I guess what we're gonna do now is so this is the underneath here. It's gonna be attached on the bottom there. I'm going to add these feet to the bottom of it. Alright, so this is finished. I'm going to set it aside for now. We're going to install it later, probably as one of the last steps. The next thing we're going to do is we're going to work on this RS-232 connection, which actually plugs in right here. And I already made one right here, but basically the way we're going to make it is we're going to use one of these connectors here, which there's a part number for it in the manual, and also one of these RS-232 connections, which will come out right here in the back. Again, there's also a part number for this as well. And we'll solder about 8 inches of I think 22 gauge wire. I'm using stranded here, and the manual calls for stranded. I see no reason why solid core wouldn't work as well, but just stranded is much more malleable. And I'm going to twist it around just a little bit like this to reduce interference, but I'm going to do it once we plug it in. So we just want to make sure that we actually wired this up correctly. So what you can do is take this connector here without wiring it yet, and just try to plug it in. And as you can see, the tabs are right here. That means it's going to go like this. We can see which one is ground. So this is going to be the ground one. And based on the manual, ground should be wired up to pin 5, which is right here. So there are pin numbers right underneath here, so you can reference that. And once you have ground, which is first pin, you can do the RX and TX as well, second and third pins. Next thing we're going to do is work on this right here. This is the power entry module, and it'll be inserted in the back, something like this. There's the part number for it as well. And if you try to open this up, you can see that this thing actually accepts fuses here, and I think these are 5 by 20 millimeter. I believe let's see, what does the manual call for the fuse? I believe it's a so it's a 3/4 amp fast blow fuse, 20 by 5 millimeter, and they just kind of get inserted into here like that. There's 2 of them. Okay, we got the fuses inserted in here, and this is where we actually select whether we're going to use 120 volts or 240 volts. And the way to do that is right here on the power entry module, there's a little arrow on one side, and that arrow needs to align with the voltages. So on the fuse piece right here, we have a 120 volt here and 240 volt here. So I'm using 120 volts, so I'm going to align this 120 volt to the arrow, insert it like that, and just push it in. And that's it. By the way, to remove it, you can just use a screwdriver to pry it open. So now we can actually wire up this power module with some wires, and the manual calls for a couple of different wires. So a green wire, and I'm going to move this aside a little bit. This green wire will have this little plug here, and I believe it's going to be mounted right here. So just some sort of, I don't know, circular thing to mount it to there. I'm using the one that's specified in the manual. A white wire, black wire, and also a yellow and blue. Unfortunately, I don't have yellow and blue, but I do have white wires, and I just color-coded them with some blue and yellow tape here, so we'll use that. And these are about 8 inches long. By the way, this green wire, I think, needs to be a little shorter than 8, so I'm going to cut it about right here and redo it a little bit. So this ground will be soldered into this ground pin right here. So I'm going to go ahead and do that. And then we can solder the white and the black wires. And if you look closely on this power module, there's a L and an N. So N is for the neutral and L is for the load. The load is usually black, so we'll use black for the load and white for the neutral. This blue one we're going to connect to pin number 2 right here, and yellow will go right beside it to pin 3. 1 actually goes to white, and 4 should go to black. I think the manual says black should go to 2, but that doesn't make sense because, well, based on the schematic, it doesn't make sense, the manual for this power module, but also because 2 is actually going to blue, so 4 should go to black. So we're going to wire black to 4 and white to 1. Okay, let's go ahead and insert this power module into here, and we want to have the switch on this side, on the edge of the enclosure here. So we're gonna insert it through the outside and run through all the wires through it, something like this. And we'll mount it with just some screws that might fit. In my case, these fit. These are 45/8 1/8 of an inch, and I'll use a washer and a nut. Okay, now we can insert this PCB board into here, and just want to make sure that we route it into the holes. Should fit pretty easily in there. Seems okay here. And we'll just use 440 screws here and a little washer. So we'll mount it with these 440 screws here, all these 3 positions. The one over there where there's like a open pad where it says ground, we're actually going to connect this ground wire to it and just mount it with one of these screws. Yeah, we don't need a washer if the head of the screw is large enough, but in my case it's not that large, so I'm going to use a little washer over top. And I just tightened them. You don't want to over tighten them. And as you can see, that ground wire, we don't want to touch anything else, so we want to route it like away from the PCB and just have it against the enclosure there. That's what it looks like underneath, and this is what it looks like on top. Got the LEDs here, got the socket here, and we can actually access this lever here, and also these trim pods for adjusting it. Next, we'll mount this RS232 socket or connection here, and we'll run it through the outside, through the hole, basically route this wire through the hole, and we'll attach it with some 440 screws here as well, and a little washer and nut, and then plug this in. Alright, let's mount the transformers next, and first we're going to mount this large one here in the back. So let me open it up, and we're going to mount it so that these contacts are actually facing like out or up in this case, so that we can actually access it. And we'll mount it with number 6 screws. And by the way, I got this set of screws. These are stainless steel screws, and you know, if you want a variety of screws, this is actually nice to have. So in this case, we need a number 6. I mean, anything really works, but let's go ahead and go with the number 6, and I think it's a 632. And I actually added some washers right here before I inserted this transformer in, and just to kind of, it's there to basically provide some clearance, because this back actually has some ribs here that may get in the way. We'll do the same for the other smaller transformer. Next, we can wire up the transformers using these wires that we just soldered to the power module, and we can use the manual for that. It's pretty straightforward. Basically, all these wires connect to both of these transformers, so the white, the black, the blue, and the yellow. So, for example, I connected all these wires coming from the power module to the smaller transformer as outlined in the manual, and then I just wired it up back with a smaller piece of wire to this larger transformer. Just keep in mind that, for example, this is what, pin 4 or pin 1, I think it's actually pin 1, connects to pin 1 here, and there's 4 pins right here. They all connect to the 4 pins here, but just keep in mind that 1 has 1 here, 2 has 2 here, but this 3 actually wires up to pin 4, and pin 4 of the smaller transformer wires up to pin 5 of this transformer. Basically, there's a missing middle pin. And then I use some zip ties to kind of organize the wires a little bit, keep them to the back as much as possible, and I think it looks pretty good. The next thing we want to do is hook up this connection here, and this is the low voltage wires coming from the transformers, and they'll connect to this connector here. And I went ahead and created started the connector here. So basically I got, I think these are 16 gauge maybe wires. I crimped them and attached them to this mating connector here, which there's a part number in the manual for it as well. And now when we plug it in like this, we'll be able to tell which pin goes to which transformer and which pin of the transformer. So let me go ahead and do that. So basically what I did, I think these wires are maybe like 8 inches long. So these are all 8 inches long, and what I'm going to do is I'm going to plug it in here. In fact, I'm going to go ahead and do that right now. Just slide in there. And now that it's in this connector, basically it's just connected the way it should go. There's only one way it should connect. Now we can actually know, or I guess trim all these wires to length to whichever pin it goes. We want to leave a little bit of slack, something like this, just a little bit, not too much, just so we have something to work with. There we have it. So pin 1 is right here, right by this heatsink, and it routes to this pin of the large transformer. And then pin 2 connects to this pin of the large transformer. Pin 3 is this blue pin, the middle pin of the large transformer. And then we have pin 4, and pin 4 routes. So pin 4 is a blue wire. Pin 4 goes right here to pin 7. It's basically the center pin of this small transformer. Pin 5 is 8, yellow, right here. And pin 6 will be 5, yellow as well. So I color-coded these wires with some tape. Okay, so now we should just inspect everything, make sure everything's okay before we do anything else. In fact, what I'm going to do is I'm going to unhook this from the PCB and check the voltages before I actually plug it into the PCB. We also want to make sure that none of these wires are actually too high up so that they don't touch this metal part of the bottom plate. So for instance, this one right here was a bit too high for me, so I kind of lowered it a little bit. That's a little bit better. Something still sticking up, I think it's just these wires right here. Just going to bend them down a little bit. I think that should do it. Plus I have this like piece of plastic wrap here that I'm going to leave it on just in case. So let me go ahead and unplug this and plug this harness back into the connector. Now we're going to measure the DC voltages. That looks good. Alright, I'm gonna power it off for now. Let's now insert the ICs into their sockets, and I have this loader here. We're going to insert into U2, and also the Max 232 IC, which will go into a U3, I believe. Now that we got the ICs in there, we're actually going to test it out. I'm going to actually go ahead and close this up with this cover here and use the bolts that were provided with the enclosure to attach it. Great. So what we're going to do now is we're going to connect a computer to this RS-232 output and test it out. So you can connect it to your computer directly if you have one of these connections here, but I will actually use this RS-32 DB9 connector to USB converter that I used in previous videos. I got this little terminal open on the Mac, to serial terminal, and on my background here there's actually a schematic that I was looking at for this programmer. But here I'm going to connect to the device that I was talking about. It's a RS-232 to USB converter, and it's right here connected to my USB. I'm going to go to options here and select one stub bit, parity of none, and then just turn this all off here, and leave the baud rate at 96 here and click OK. I'm gonna click connect, and now I'm gonna plug in the power into the programmer, and we should see something on the output here. Awesome, that's good. That means it's working. So we should have two LEDs on, the blue and the green. Now let's try to type something in and see what it does. I'm going to type in question mark and press return. And it gives us a bunch of options on programming, reading, and so on. The next few steps in the manual go through a testing process to make sure that the pins that are outputting on the U1 IC or the ZIF socket are actually correct, and I would recommend going through that. I actually went and done that already. So I'm going to go ahead and install a 1702 EPROM into the ZIF socket and do some testing with it. I'm going to type in dB, and that's the default buffer that's being displayed, and right now it's just nothing. Let's fill the buffer with some random data. So I'm going to type in FB, fill buffer, with 55. And it says buffer filled with 55. So if we type in dB again, we can actually see all those 55s in the buffer. And we can try it again. So type in FB AA, and it's going to fill it with AA in the buffer. And we can now basically load files into the buffer and read from the buffer and so on. But before I do that, I'm going to do something else, and what I'm going to do is I will actually type in another command called EB, and as you can see it says error address EPROM 13 12 EPROM fail. I'm going to type in ER, and it read the EPROM into buffer, and let's type in dB to actually see what's in the buffer. Okay, so I guess that's what's in the buffer, and it doesn't look like it's blank to me. So I'm gonna try a different EPROM. I think I had some blank ones. I'll try another one and see if any of them are blank. If not, I'm gonna try to erase them. Okay, so this one is all FF, and I'm not sure if that's actually a blank or not. I think it has to be 00 for it to be considered blanks. Regardless, let's try to do something with that. So I'll type in FB and just fill buffer with some random data. And I'm going to modify the buffer a little bit. So I'm going to type in 1, 2, 4, 8, 10, and just kind of start filling random data into this buffer. Then press Ctrl C. And let's see what the buffer shows now. So, dB. Okay, so we're showing 1, 2, 4, 8, 10, 20, 40, 80, 88. Basically what we just typed in. Then I'll type in EP. And then I'm going to say yes and press enter. Hey, look at that. EPROM matches buffer. Let's fill buffer with zeros and run ES. So let's type in ER to read the buffer. Okay, EPROM checksum AC, EPROM read into buffer, checksum AC. Okay, and then type in DB. Yeah, and we're seeing the data we just programmed. And just to make sure, I'm going to turn off or unplug the programmer and plug it back in, and we're going to try to read it again just to verify. Okay, and now I'm going to type in ER again. Yeah, AC checksum DB, and we're seeing that data. So it looks like it was written. All right, let's try programming the EPROMs that we have with the SCELBI data. And I believe I have enough EPROMs for the entire ROM board, or at least most of the pages there. But let's go ahead and see if we can actually get this the SCELBI data. So we're going to go to SCELBI.com. I'm just going to type it in here, SCELBI.com. And there's a couple of things here. There's some emulators. So there's Mike Willigle's SCELBI emulator if you want to check that out. There's a CELBAL, I guess. There's assembly code for that, hex for it, Intel hex. Monitor editor assembler, hex. But there's also these ROM pages. So basically we can download each page here, and we'll use each page to load it into our EPROM. So each of these files is a separate EPROM. So if we have, how many do we have? 4, 8, 12, 13, 14. So there's 16 of them. I'm not sure if I have 16, but I'll just go ahead and start with, like, for example, page 60. I'm going to click on this. And it actually downloaded right here. It's page 60.hex. It's an Intel hex. Yeah, so this is the Intel hex for page 60 of the EPROMs. And we're going to paste this into our terminal here once we set it up. So let's go ahead and do that. So I'm going to open our terminal back up again, and I'm going to power on the programmer. So the first thing we want to do is actually specify the page from this file here. So I think it's actually 30 right here. So 1030. So in this prompt, we're going to type in PA 30 or 30. And I just pasted the contents of this EPROM P60 file into this programmer. And as you can see, it executed it, and it says 11 records loaded in page 30. Bad record 0. Okay, that's good. And let's just verify that the data is there. I'm going to type in DB, and we can kind of take a look here. So the first one was 44, and then 30, 32. So it looks like it has the right data in the buffer right now. I'm going to go ahead and type in EB to check if the EPROM is blank. I have a new one in there, and it says EPROM is blank. Okay, that's good. And then I'm going to type in EP to start programming that EPROM with this buffer data that we just loaded. I'm going to say yes. I actually went ahead and programmed the monitor prompts right here, the page 60, 61, 62, and 63. So we got all 4 of these prompts configured and programmed. Just FYI, these prompts can be cleared or erased with an EPROM eraser, basically UV light, and it might need about 30 minutes or so depending on the EPROM. But yeah, it seems like most of these EPROMs are working and operational. Of course, I'm still erasing. You can actually probably hear the eraser in the background. It's like a little timer. But I'm still erasing the majority of them. And here I have them. I actually labeled them. So it's 60, 61, 62, and 63. I added some tape here over top of the little window just to make sure they don't erase. I also have the EPROM eraser right over here. Let me just show it to you. It's very basic, very simple. It has an on and off switch and a little timer, and a little holder for the EPROMs. As you can see, I have some in there right now, and the UV light is on. So that's pretty much it for now. I will program the other EPROMs a little bit later, but what I want to do now is actually insert these EPROMs into the SCELBI computer and try them out. Got the SCELBI computer right over here, and I'm gonna remove the PROM board from the rear here. I'm gonna set this box aside. We don't need it anymore. All right, so the pages start from here. So this is gonna be 60, and it goes through 68, I believe, and it goes up to 77, I believe. So let me go ahead and insert these EPROMs into their positions. All right, that looks pretty good. And let's go ahead and reinsert this board into the SCELBI computer. I will go ahead and power it on and see what we're seeing on those ROM locations, memory locations. Alright, so the way we're going to verify it is that we want to see what the memory contents are on the prompts. And the first prompt, the P60 to page 61. It starts at memory address 30, that's the high address, and then 00, low address. So we just want to start from there and verify that the contents are actually correct. And at address 30, the value should be 44, and then it should be 30. So let's go ahead and turn it on. And we'll set the high and we'll set the high address to 30, interrupt, step, and then we're going to set it to 30 hex, that is. So 30 hex, so that's 060 in octal step, and then set the low address to 00. Okay, so what we want to do now is actually read from the memory address and just write it somewhere. So I'm going to write it to register A. So the way to do that is to actually run this command. So it's 307 in octal. We're going to step, interrupt, and then step, and then step one more time just to see what it read. And there you go. We're actually seeing 44 in hex, or 104 in octal. And that's actually the data that we're expecting based on the Intel hex file from the SCELBI website. I'm gonna increment the address. So we're still at high address 30, but the low address will be 01. And then we're gonna read the address again. So 307, interrupt, step. Sorry, I did not interrupt it. Interrupt, step. One more time. And there you go. We're seeing, what is that? 30. Right, so that's the correct memory address. And the next one should be 32. So let me increment one more time and read from there. Should be 32. Interrupt, step, 32. Perfect, so we are able to read from the prompts, at least the first one. Alright, now let's see what will happen if we actually run the program at memory address 3000, I guess? Yeah, 3000. By the way, the prompts are actually labeled 60, 61, and 62, and so on. The reason why they're labeled, those are actually octals. So for example, this would be 30 in hex, but it's actually 60 in octal, so it will be 060. It's just they're omitting the early part, the beginning of the octal. Anyway, let's go ahead and run from address 3000 hex. So I'm gonna do a jump instruction 104, interrupt, step. Status light is on, and I will enter the low address, which is 000 in octal, or 00 hex. Keep on switching between the two, unfortunately. I'll press step, and then I'm gonna do 060 in octal, or 30 in hex, and press step. This is the high address. Alright, so if I keep on pressing step, okay, so we can see there's a 30 right, yeah, so 30 in hex right there, and the next one would be 32, I believe. Yeah, so it's actually going through the program right now and executing it. Now, if we can continue this program, it will get to a point where I believe it will just stop, and the reason why is because it'll be waiting for an interrupt. Yeah, so it actually stopped. So I believe what happened now is that we don't see it here, but I believe what happened is that a prompt was actually returned on an output port, and it's supposed to be displayed on some sort of output device, and unfortunately we don't have an output device connected to this SCELBI computer, so we can't really see it, but we do see that the program is actually executing. In the next video we'll probably tackle one of those output devices, just so we can actually get an output from the SCELBI computer and see what's actually being returned from it. And this is what the final product looks like for this programmer. I added some labels here, so we have a power, we have a ready and a busy label, and also just a text for this programmer, the ME1702A programmer, just to use the labeler for that. And this Enclosure is easy to smear, and as you can see, it's easy to get dirty. But yeah, this programmer seems to be working pretty well. Thank you, Martin. Thank you for watching this video, and yeah, in the next video we'll probably build one of those I/O devices so we could actually test out these EPROMs that we programmed and actually test out the entire SCELBI computer, or at least the output of it. Thank you for watching, and I'll see you in the next video.